What we have here is a data visualization installation that we have titled Energy Pools. And this piece was commissioned by the Irving Institute here at Dartmouth. And what you have represented here is the 2018 energy usage for the United States. We have 1,013 strands on the exterior representing 101.3 quadrillion BTUs of energy consumed in the United States in 2018. In order to not have to represent this fractionally, we have 10 strands per BTU to equal 1,013 strands. And the different colors signify different energy sources. So the blues are natural gas, the black, red, brown spectrum is petroleum. Around on the other side, we have greens for the range of renewables, reds, oranges, and yellows for nuclear energy, and then gray for coal energy. But we also wanted to be really conscious that the form echoed some of the concerns around energy consumption and our need to move towards renewables in the piece itself. So what you see here in some of these sort of more banded textiles are recycled chiffon or silk from factories that make silk and chiffon garments. Many of them come from India, although not exclusively. You also have recycled yarns and renewable sources, like this is from wool roving, natural wool roving here in the United States. And we have significant sort of bands of this natural wool roving in each of the colors as well. And these are also sourced from all female-owned companies. And so we wanted to have our piece reflect the sort of ethos of the lab and the creators, right, in thinking about not just the sort of alternative way of representing the data, but also thinking about environmental or climate justice and data justice principles.
I came onto this project when Jackie had already chosen that she wanted something large scale, wanted something textile based, and then we worked together to determine exactly what form that would take. And so what you have here is a variety of textiles, and the goal here is to really have people interact with energy data that you might always typically see in a 2D format in like data systems that are kind of like predetermined to have a number of outcomes. You know, typically if you look at a graph, there's only so many different ways that computer systems allow you to make a graph, whereas this, we really got to make choices about how we wanted to present the data and what the best and most interactive way would be. And what I love about this and being right here is that you can really see that and you can feel it and you can feel the weight of it in front of you because it's, I mean, it's larger than I am. And so it goes all around and represents all of the different sources of energy in the US, but the goal here is to really have a big, large-scale installation that is an alternative way of presenting data.
So we wanted to have a piece that would represent some change over time. And this is something that we thought about and prototyped a number of different versions of. And what we came to was that the exterior of this piece would represent 2018. That's the year for which we had, when we started this project in 2019, we had the best data. So the exterior represents the state of affairs in 2018. And then the idea was that we wanted people not only to sort of look at it and think about the proportion of energy that came from different energy sources, but we wanted them to put some work into thinking about energy transitions for the future. But what we plan to do is to use the IPCC's recommendations for capping carbon emissions and keeping global warming at 1.5 degrees Celsius by 2030. And so in order to do that, a certain amount of, in this case, petroleum has to be sort of closed out of the system. And so we're going to ask people to braid these sections as a way of representing, right, the closing off of that particular energy source. And then what you have behind and inside are strands that represent the rather dramatic change, actually, that we'll need to see in order to reach that IPCC goal by 2030, which is a shift towards renewables. So it runs all the way through the piece, and we will do a significant amount of braiding to make this visible. But what you will see is that there will be a 49% representation of renewables in 2030 once this whole piece is transformed.